So guys, here you can see one more timing came on the Code with PK's channel, and this was part 12 on our DSA of Array. Okay, this was part 11 in which we are covering minimum adjacent swaps required to sort binary, and this was part 11 of the Code with PK channel. Okay, so get ready for it. Sorry, not part 11, part 12. Okay, this was part 12 which we are covering in today's video, part 12 of Array DSA. So get ready for it, and please like the video, share, friend, and subscribe to my channel, and don't forget to all the notification bell also, so you never miss our these type of videos on this channel. So now let's move to the computer screen and let's learn about part 12 of this channel. So now let's move to the computer screen, and now let's do a coding with laughing. So guys, in today's video of the DSA of part 12 on this channel of the array, I'm telling you about the minimum adjacent swaps required to start binary array. So this is our topic on the channel. So let's start and let's talk about it. It is given a binary array. Task is to sort this binary array using a minimum swaps. We are allowed to swap only adjacent elements. So this is one example. It has been given me the examples. So if you give the input 0 0 1 0 1 0 1 1, so output will become 3. Okay, because first output will become 3. Why? Because first of all, first swap is 0 0 1 0 0 1 1 1, means that first swap will become like this, like the real one is like this. Let me show you where it is. Okay, real one is like this. Okay, let's do this and let's do this. Okay, so this is like 0 0 1 0 1 0 1 1. So then we will swap. Here I write where we write 1, means here in this, here we swap. Here where we write 0, there is write the 1, and where we write 1, there is a 0. So I have swapped, then I write here 1 and I write here 0. So that's why it is coming like this. Here you can see there is some changes. Let me show you. Here you see there is changes here. Let me show you one more thing. Okay, here it has been changed. I hope you understand what I am trying to say. Okay, here you can see it. Here is 1 and here is now 0, and there is 0 and here is now 1. Perfect. Now in the second swap, what we can do, in the second swap, what we are doing here, the second swap will be look like this, 0 and 1. Okay, the second swap will be looking like this, 0 and 1. And because the 0, okay, let's copy and paste it. Okay, like this. Here you can see it. Now because there is 1 and 0, and here I swap 0 and 1, so the second swap we have done. So 0 and 1, so the 1 has become here. In the third swap, what we are doing, in the third swap, I write here 0, we swap 0 with 1. Okay, here we swap 1 0 with 1, so the here in the line, on the all the line, in the 4 line, there is come 1 1 1 1. Here you can see it, like you have seen it. So the output will become 3, because in the third swap we solved this. Okay, so that's why the output has become 3. Input, if you give this input 0 1 0 1 0, so output will become 3. Why? Let me tell you. First of all, the original array is looking like this. Let me show you. The original array is looking like this, 0 comma 1 comma 0 comma 1 comma 0. So the y output has been coming 3, because we write 0 comma 1 comma, then 0 comma, then 0 here we write, then 1. So this is the first of all, let's comment it here, first swap. Okay, because in the last the 1 has been came. Now one more swap, second swap. In the second swap, what we can do, we write 0 comma 0 comma, then 1 comma 0 comma 1. So this is the second swap. Okay, so here in the third line, line there 1 has been came, and in the first swap the 1 is in the second line. So the third swap we can do like 0 comma 0 comma, then 0 comma, then 1 comma, then 1. So you can see it, that's why the output has become 3, because in the third swap we sorted our array. So that's why the output will become 3. Now let's unzoom it. Recommended. Please try your approach first on ID and then look at the solution. Approach. This can be done by finding number of zeros to the right side of every one and add them. In order to sort the array, everyone always has to perform a swap operation with every zero on its right side. So the total number of swap operations for a particular one in array is the number of zeros on its right hand side. Find the number of zeros on the right side for every one. For example, the number of swaps and add them all to obtain the number obtain the total number of swaps. Now, let me tell you the steps to solve this problem. First, declare an integer array no of zeros of size n and initialize it with zeros using memset function. Number 2, initialize a variable count to keep track of the total number of swaps required. Number 3, initialize one variable I to traverse the array from the end. Number 4, calculate the number of zeros on the right side of every one and store it in the number of zeros array. This is done using a loop which starts from the second last element of the input array and goes till the first element. For every iteration, the value of no of zeros in square bracket I is updated with the value of no of zeros square bracket I plus 1. If the current element of the input array is 0, the value of no of zeros and square bracket I is incremented. Number 5, a loop. A loop is run over the input array to count the total number of swaps required for every iteration. If the current element of the input array is 1, the value of count is incremented by number of zeros. Number 6, the function returns the value of count, which represents the minimum number of swaps required to make all ones integer. All ones together. So there is one implementation of the C++ code. So let's run this code. So we have copied this all the code. So let's run this code. First of all, let me come down. So let's copy the code and the output will become 3. Why? Let me tell you. Because we swap it 3 times. Swap it 3 times. So that's why the output will become 3. So let me show you. First of all, let me come to the Google and let me search here Replit, in which we run our C++ file. So it take a little bit time to open it when it had been opened. So let me open my C++ file, and when I open my C++ file, so it take a little bit time. So it has been opened. So let's paste this code and then run it. So let's see the output. Now output will be coming. Let's see the output. So output will be coming 3 because this one array here you can see. Let me show you this one array. In this array, first swap we can do this one array. The first swap will be look like this: 0, 0, okay, 0, 1, 0, 1, 0, then 1, then 1. Okay, this looking like this. So how we can swap it? We do this. We write here 1 and then 0. Here we swap first one. Then the second swap will be look like this. Second swap 0, 0, then 0, then 1, then 0, then 1, 1, 1. So like this is called the second swap. Now third swap will become 0, 0, 0, then 0, then 1, then 1, then 1, then 1. So like this, in the third swap we sorted our array. So that's why the output has become 3. So if I add one more number here, let me show you. If I write here if I wrote here one more number like this 1. So now let's see the output. Then the output will become let's see. Now output has becoming 3 because it is the same. Okay, so that's why. If I write here 0, so now the output will become 4. Okay, let me show you. Here you can see it. Now 7. Here you can see it. Like this, output has been coming 7. So why? Because here you will be swap it 7 times, then you will sort it the array, so that output has been coming 7. Time complexity O(n), alloxary space O(n). Space optimized solution. An alloxary space is not needed. We just need to start reading the list from the back and keep track of number of zeros we encounter. If we encounter a 1, the number of zeros is the number of swaps needed to put the 1 in the correct place. And this one implementation which is it's showing me. Here you can see it. And the output will become 3. Okay, let me show you. Paste and this one array here you can see it. the output will become 3. Let me show you. Here you can see it. The output has been coming like 3. So here you can see in today's video of the DSA, I am telling you about the minimum iteration swaps required to sort the binary array, and this was part 12 has been ended very successfully as. So get ready for our part 13 of this DSA part of the array. So get ready for it. So I hope you enjoy this video. So if you enjoy, so please like this video, share your friends, subscribe to my channel, and don't forget to all the notification bell also. So you never miss our these type of videos on this channel. So now let me meet you in the next class and next very amazing like that type of videos. So now for today, goodbye.